Hi, in this video I'm going to show a different example on simple interest. So normally when we have a problem on simple interest, what we're looking for is basically the interest, and that is simply found by multiplying the principal P, the rate of interest, and the time, which is in years. But there are problems in which sometimes the missing is R, or the missing is P, or the missing is time. So in this particular example, I'll be showing you a problem in which the time is missing. And common to these questions are like finding the time when the amount is already twice its value, the principal is twice its value after some time, or in some cases we have problem on when it will triple its value. So, but doubling, tripling, or the value becomes 4 times, the approach is just the same. So let's take one example in which the amount will be doubled after some time. Okay, so let's take, for example, the problem here is after how many years will an investment double its value under a 3.5% simple interest rate. So it's clear that what is missing is the time. So interest is equal to P, R, and then the T. Also take note that any future amount, or what we call the future value, is just the principal plus the interest, in which we learn that this is P plus PRT, or equivalent to P times 1 plus RT. So this is also something that we can use when it is needed. Okay, so take note of the formulas. I, that's for the interest, and A for any future value or future amount. Now, going back to the problem, after how many years will an investment double its value under a 3.5% simple interest? In this kind of problem, it is better to apply the future value formula, because it says about the future value of the investment, and that is when it is already doubled the principal amount. So if we will apply, or if we will use the information stated in the problem, that means we are concerned about having the P to become 2P, in which 2P is the future amount of P. So if we apply the amount formula, which is P times 1 plus RT, the time that we're looking for is the time when A becomes 2P. And immediately, you will see that with this setup, the P will cancel with the other P. And the equation becomes 2 is equal to 1 plus RT. And if you continue, this is 2 minus 1 equals RT, and 1 is equal to R times T. And from here, it's very easy now to find the T, because we already know what's the R. So if we will place the R, which is given in the problem is 3.5%, then this will become 1 is equal to 3.5% is 0.035 times the time. Dividing this both sides by 0.035, then we will get the exact time. This T is equal to 1 divided by 0.035 is 28.57. So it'll take it about approximately 29 years. So that's how long it will take a certain value, any random value, under a 3.5% simple interest rate to double its value. And if you will observe, the formula that we obtain here can be used as a general formula whenever we want to find the time for a value to double its value, or for the principal to double its value. and that is simply 1 divided by any given rate. Okay, so an immediate follow-up to this would be, what if the rate is changed into 6.25% simple interest, and you want to find any principal amount to double its value. So for how long will it take for that P to become 2P? That formula that we have seen earlier, 1 is equal to RT, is the only formula that you need. Okay, because this is only needing the value of R, and 1 is always 1. So to find the time, so the time is simply 1 divided by R, and if R is 6.25%, then that's 1 over 0.0625. And immediately it will give you the value for the time, and this will take 6 years for any value to double given the 6.25%. See, so a shortcut, this could be taken as a shortcut. If we talk about tripling its value, then we need to derive a new formula for it. Okay, but the long way of doing it is by starting with the future value formula and then supply the corresponding value. Like for A to double, so you use 2P. If I say triple, then you use 3P. And from there, you can create a new formula that when you encounter the same or exact problem, then you can immediately apply the formula and you can find the time very easily. Okay, so what about if you're given an exact amount? Let's say, suppose the principal amount is 25,000 and the rate is, say, 7.2%, and it's under simple interest. The question is, when will it double its value? Now you could think of that as to double its value. That means you need a future value equal to 25,000 times 2, which is 50,000. So applying the formula, the future value formula, A is P1 plus RT. That will be 50,000 equals 25,000 times 1 plus the rate is 0.072 times the time. Dividing both sides by 25,000, of course you will get 50,000 divided by 25,000 is 2, and you have 1 plus 0.070, and by transposing 1, that's 2 minus 1 is 0.072 72t. And that's exactly what the formula was telling us earlier, that it's equal to 1 equals the rate times the time whenever we are interested in the time when the principal amount is already double its value. Okay, so you can do the long way, or you can do the shorter way, that's 1 equals RT, to find the time. Again, this is used only when the amount or the time is as when the amount is already doubled its value. Okay, try to experiment. What if it's tripled? If the value, the principal amount, is already triple, 3 times its value, you will see a similar formula, and I need you to explore on that. Okay, find a new formula so that when you encounter a problem like it, tripling its value, then you will be able to find the time easier or faster. Okay, so that's my lesson for this video. This is a specific example on simple interest when we're looking for the time given that the amount is being doubled or being tripled. I'll show, or I'll create another video of a similar problem, doubling and tripling its value, but this time it would be on the compound interest. Okay, so this one that I have made is on simple interest. Okay, that's it.